Hi, ladies and gentlemen. This is another in my series of Algebra 2 lessons, trying to get through this series and sequence stuff. And we're going to be looking at some more of the sigma notation and some of that information today. What we're going to look at specifically in arithmetic sequence, like this one right here. I'm sorry, in an arithmetic series, the series that results from adding up the n terms of a sequence is called a partial sum. So if you start with this system sequence here, then this corresponds to the series. Okay, you can define the sum of all those things right here. Okay, but because this goes on forever, notice the dot 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 down here, these ellipses down here telling you dot dot dot. Okay, goes on because that sum goes on forever and ever and ever. A sub n represents that last term that you might have in here. Okay. Let's say that you're interested in the first n number of terms. That's called a partial sum. Okay? So the whole sum would be adding up all of them that might be in the sequence, but the sequence might go on forever and ever and ever. So if you're adding up some fixed number of them, it's called a partial sum. That's what we're going to do. Is we're going to add up some fixed numbers of them. Now, smart men, lot smarter than me, worked out the ability to come up with a formula for this. Okay, instead of having to write out all the numbers, all we got to do is find the first term, the last term, and take that n divided by 2. Now this is in an arithmetic sequence, an arithmetic series. We can find any partial sum by knowing what number we're looking for. For example, down here in A, it says find the sum of the first 100. So we're finding the first 100. So guess what? N equals 100. Okay? And we're going to do the even integers, right? So let's see, if they're even integers, basically it's going to be 2n, because that's going to be the even integers, isn't it? And if we want to find the summation of the even integers from n equaling 1 to 100, let's see, you stick a 1 in there, we get a 2. You stick a 100 in there, you get 200. Okay, so we're adding up everything from 2 to 200 even numbers. Well, I'm going to use the formula up there. Okay, I'm going to take 100 divided by 2 times 2 plus 200, right? Well, this is 50 times 202. Okay, calculator time. Dun, dun, dun. I'm going to reach in here and grab my calculator real quickly, and I'm going to take 202 times 50, clear, 202 times 50, and I wind up with 10,100. So that sum is 10,100. Now I want you to think for just a second. If you were having to add up all of those numbers by hand, adding them all up, that would take a long time. So that's what we're trying to get to, is something that's a little bit easier than taking a long time to do. Remember, I'm all about easier. I want to do things the easiest possible way. Let's look at B here for a second. It says find the sum from I equaling 1 to 17. N equals 17. So that's going to be 17 over 2 times. Okay, stick a 1 in here. So 2 times 1 is a 2, plus that's 7. Plus, stick a 17 in here. That's 34 plus 5. That's 39. Wow. That wasn't difficult at all to stick those numbers in there to find those values, was it? So let's see what we get. Okay, 7 plus 39. Since that's in parentheses, we've got to do that first. That's equal to 46, right? So we got 17 over 2 times 46. Well, the 2 goes into the 46 23 times. So I'm just going to have 17 times 23. 17 times 23 is going to be 391. Hope you see how that was not that difficult to do. Just was a matter of doing a little bit of mathematics there, wasn't it? And I'm going to stop the recording here. Okay, sorry about that. Just need to stop it for a second because I realized I wasn't showing you my calculator as I was going along there. But that's all I'm doing to find these answers. It's just using the normal add, subtract, multiply, and divide. I'm not doing anything special with these at all. At all, at all. Okay? So let's go to number 4, my next slide here. In this one, it's saying that we have an alternate formula for finding the sum of the uh, first n terms of an arithmetic sequence. Okay? This formula is a little bit harder. It takes n over 2 times a1 plus n minus 1 times the difference. Why would it do that? Because we might not know what the last term is. We might not have it in that format. We can know what the difference is so that we can go from one to the next, but we don't know what that last term is. In other words, we don't have this little formula here for what the nth term is, or we can't just pick it out of what they're saying. So let's look at these. If I want to find the 20th first 20 terms, that means n equals 20, right? And we're doing this. We're taking negative 30 minus a negative 35, so we got a difference of 5. That means d is equal to 5. So I can find this summation from n equaling 1 to 20 of, let's see here, the difference is 5. So let's see here, we're going to start at, let's see here, let's go from 0 to 19. This always seems to work better for me when I do it this way. 0 to 19 of n times 5 minus 35. Okay, I took that difference. You see where I took that difference, that d here, n minus 5, that 5 there, and I took the n being 0 to get there. This is what we're taking the partial sum of. But I'm going to use this formula right up here, and I'm going to plug it in. So let's see here. We have 20 divided by 2. Why did I use 20? Because there's 20 terms that we're doing here. Even though I started at 0 and doing 19, that's still 20 terms that I'm counting up there. Okay? So 2 times negative 35 plus n minus 1, that's 19 times 5. Okay? Okay, this is equal to 10 times negative 70 plus 19 times, let's see here, 19 times 5. So let's see here, negative 70 plus 19 times 5. And what do I get when I do that? I get 25 times 10. I get 250. Move it back off, look back up here, and get 250. Okay. Now this one says find the sum of the first 14 terms in an arithmetic sequence where C1 is 32,000 and the common difference is 150,000. I'm going to use this formula here. I'm going to plug it right in down here. Okay? So I'm going to have 14 over 2, 7. 2 times 32,000, 64,000. Plus 13. Where'd the 13 come from? That's that 14 minus 1. 13 times, the difference is 1,500. So this is just a matter of plugging it into the calculator and doing it, right? So I'm going to come over here and take my calculator, and it's 7 times parenthesis 6,400 plus 13 times 1,500, and I hit enter. Oh, I did something wrong. Okay, it doesn't like that parenthesis there. Okay, and I got 58,400. I'm sorry. I got 584,500. Hopefully you can see from doing that, it's not something you want to be adding up. It's something you want to use the calculator to do. You want to use this formula because it's going to be much easier to use. One more thing here. Let's look at this. It says the graph of the first 5 partial sums of an arithmetic series. They want us to actually do some graphing here. Okay? So let's see here. If we were just adding up the first term in this partial series, we'd get 1. If we were adding up the first 2 terms in this partial series, we'd get a 3. If we were adding up the first 3 terms in this partial series, we'd get a 6. If we were adding up the first 4 terms in this partial series, we'd get 6, 9, 10. If we were adding up the first 5 numbers in this partial series, we'd get a 15. So let's see here. Since they're all even numbers, let's just put our y-axis right here. Y. And we'll put our x-axis way down here at the bottom so that we can get it all in. X. And at 1, our value was 1. Now, that's not too hard. You know what? At 0, it was 0 too, so I'll put that one there. And then there's 1. And then let's use a different color so that we can see these things. So 0, 0, and 1, 1. Okay? At 2, our value was at 3. So there's 2, there's 3. At 4, our value was 10. 1, 2, 3. And see, I'm at 3. 4, 5, 6. At 4, it's at 10. 7, 8, 9, 10. And at 5, it's at 15. 1, 2, 3, 5. Could be up here. And if I connect these all, you know what? If I'm not mistaken, that looks awfully much like a quadratic, doesn't it? Looks almost like a parabola. B-O-L-A-H-A. Right? It almost looks like a parabola there. Well, in effect, it is. Okay? And you're going to see that later on as we go along. But that's what we're looking at here, is looking at those in a slightly different way, aren't we? Okay. Well, after you read the lesson and work the problems, I think you'll probably understand these sequences and series a little bit better. And the more you work with that sigma notation, the more you're going to appreciate it. Okay? So I'll look forward to talking to you next time.